My name is Muhammad Izzatullah bin Yusuf from the MTA section 11.
My name is Josizar Akmal from the MTA section 11.
My name is Muhammad Dani Hakimi from the MTA S11.
First, remove the screw to remove the oil reservoir bottle using screwdriver. Remove the reservoir tank from the master cylinder carefully using screwdriver. Disassemble the rubber from master cylinder to check whether it's rotten or not. Next step is open up the cap to remove the filter. Now using the plier to remove the filter inside the reservoir tank. And then check the condition inside the tank reservoir. Next, remove the piston stopper to loose up the secondary piston. Now we need to tap up the master cylinder on the wood to remove the piston inside it. For the inspection part, we can see that the inner surface of the master cylinder is smooth and in a good condition. And then the primary and secondary piston is in good shape for working properly.
break the component, put some grease around the piston ring. Push the secondary piston into master cylinder. Lock the piston inside using the piston stopper. Measure up the pushrod end with the vernier clipper when the pedal is not pushed. This is a reading for before condition. Brake pedal push, then the push rod end is out to its limit. Then measure back the after condition. The reading are 48.58 mm for after the brake pedal push. Install back the master cylinder onto the brake booster. Assemble back the rubber ring on the reservoir tank. Install the reservoir tank back on the master cylinder.
This is the another type of master cylinder. Firstly, unscrew the screw to remove the tank. Then remove the lock pin using the plier. The first piston is removed. Then tap the body to remove the secondary piston. The piston is in the good condition. The spring also in a good shape. The lock pin are no need to be replaced. The condition inside the master cylinder also in a smooth surface. Then we put some grease around the rubber to lubricate it. Put the first piston into the master cylinder with the spring. Then the second piston is installed. Using the plier, install the lock pin to make sure the piston stay inside the master cylinder. Lastly, assemble the tank reservoir to its body. So the assembly is complete. Thank you.
For the result, Table 1, Master Cylinder Part Name. First, Reservoir Cap Assembly. 2 is Filler. 3, Reservoir Float. 4, Strainer or Filter. 5, Indicator. 6, Sensor
Brake fluid. 7 is piston stop bolt. Number 8 is reservoir tank. 9 is seal.
10, Stopper Piston. 11,
Dust cover.
12 and 13, Primary and Secondary Piston. 14, Master Cylinder Body. For Table 2, Condition of Master Cylinder. First, inner surface of Master Cylinder. The condition is smooth surface. 2,
The primary and
secondary piston.
are good for working
Properly. 3, diaphragm. Works well. 4 is brake booster. In an excellent condition. 5 is O-ring. The rubber is not firm. No need to be replaced. For the Table 3, inspection of master cylinder. Push rod end. The condition before is 26.0 mm and after is 48.58 mm.
Now we move to the discussion part. There are some questions that we should answer. The first one is based on our finding. What is the effect of the push rod length on the brake? In our finding, the initial push rod length is 26 mm. After push the brake pedal, the length of the push rod is 48.58 mm. So the different length of push rod is 22.58 mm. So we can consider that the longer push rod and reduce brake pedal travel and free play. It also allowing earlier engagement, while shorter and increased free play, causing pedal feel looser and delay engagement. The second question is name the type of brake oil used for your car. Can a different type of brake oil be used? Why? The name of our type of brake oil is .3. We can use a different type of oil such as .4 and .5.1. Switching between .3, .4 and .5.1 type is possible, but using a type that not recommended by the manufacturer could affect braking performance. It is to make sure the braking system is work properly and work safely. Next, the third question is name hydraulic tubes that are connected to the master cylinder and where all tubes are connected. The answer is the name of hydraulic tube is brake lines. It is connected to the brake proportioning valve and or ABS module that comes from the master cylinder and ensure each will receive the suitable braking force based on condition and load. And the last question is what is the function of the diaphragm? The brake booster diaphragms make braking smooth, easier and more effective by using vacuum pressure to increase the force applied to the brake master cylinder, which is allowing the driver to press the pedal less hard.
In conclusion, the inspection we found that the brake pedal push rod end extend from 26 mm to 48 mm. It requires 22.58 mm of differentiate for proper engagement. A longer push rod reduce pedal travel and free play, while a shorter one causes delay engagement and a looser pedal feel. The braking system is in good condition with smooth master cylinder surface and functional primary and secondary piston.